Hello guys, my name is Sergio. In this video I'd like to upgrade existing WebSocket Service API to handle multiple connections and share the data between those connections. So shortly, one client is sending a message, all the other clients connected to the same server will have to receive that message. Pretty much the same way like a chat works. Someone sends a message in the chat, all the other participants in the chat receive that message. So first of all, I won't need this integration response. The Lambda won't respond back right away to the current client. We'll have to send that message coming from the client to all existing clients. So let's remove this integration. And the second thing which I need right now is to store somewhere the existing connections. So all the clients connected to the server should be stored somewhere. And I'm going to use DynamoDB for this purpose. For those who don't know, DynamoDB, it's a NoSQL database from AWS. And I'm going to create a new table called messages. Partition key is going to be connection ID. This is going to be my connection ID, WebSocket connection ID. And create the table. While the create table is creating, I have, by the way, to add some permissions to our lambdas in order to write into the database. So I'm going to the lambda functions, existing lambda functions on connect. I'm going to the permissions. I'm finding the row which was created with this lambda function. And I have to attach new policy called DynamoDB. I'm going to provide a full access so it can actually read, write, scan, delete from the DynamoDB table. For your production application, you should be very careful with this thing. You should provide only the right level of privileges. For this tutorial, I'm okay with this because I will delete anyway after this tutorial ends. So attach this policy. I have to do the same thing for the other lambda. So for a message, when someone is sending a message, it will have to go to the database, to scan the database, to retrieve the list of connections, and to send that message to all the existing connections. And in order, by the way, in order to send from the Lambda to call the API and send the message to all the connections, it needs another right privilege called the invoke API, invoke gateway, API gateway, invoke full access, this one. Attach the policy. And I'm going to create a new lambda which will handle these connections. So when one client is leaving, is disconnecting from the server, that lambda will have to remove his connection ID from the database. So let's actually go ahead and create this lambda function, kind of function called on this connect. The same thing, Node.js, create a function. And when the function is ready, I'm going to add the same permissions to delete from the database. I'm going to add the full permissions, but it should only have actually normally the delete privileges. So DynamoDB full access. And here I think you can actually define your role only for delete. No, not this one. It's well, for the table that it should have only delete privileges, but I'm going to attach anyway the full access. So attach it, attach the policy. So it's done. And let's go and update the connect lambda. So lambdas connect, and then here I'm going to use the right code. So when someone connects, all the code, by the way, which I'm using here will be on my GitHub, and the link will be in the description of the video. I'm going, and shortly what this code is doing, everything starts with the handler. It retrieves the current connection ID from the WebSocket event, and it's adding that connection into database via this function. So this is using the DynamoDB API from AWS SDK. from npm, and it's putting a new record into the table called messages with the item connection ID which is coming from WebSocket as well. And we have to save this one, and I think we can go ahead and test this thing. And let me open the DynamoDB database to make sure we don't have anything in there. Tables, messages, items. So the table is completely empty. And right now, when I'm going to connect to this server, let me grab the URL for the WebSocket server. Stages, my test environment, connect, successfully connected. And right now in the DynamoDB, I should see one connection ID. Connection ID, this is one. Let's create the disconnect handler for my API gateway, which will actually remove the connection from the database. So I have my Lambda function ready on disconnect. Save it. Okay, we give it the permission to invoke the Lambda function. It should be ready, the same flow. Let's go into the Lambda function and update actually the Lambda function itself to delete the message. So the code is pretty much the same like on connect. The only difference is that in here is deleting. Instead of put, it deletes from the table messages, it deletes the connection ID coming from the WebSocket event. Let's save this one. Let's go back to our API gateway and we have to deploy the new version. Test, let's make it version 2.0.0. Deploy it. Grab the URL. Let me go to DynamoDB, make sure we don't see any items in here. Let me remove it. Delete. And right now when I'm trying to connect here, connect, successfully established, I should see an item here, and when I close this thing, the client, I should see no connections in the database. So let me refresh. It's empty. So on connect and on disconnect, both Lambda works fine. And right now I have to define the next Lambda, which is on message. When someone sends on message, I have to scan the database to grab all the connection IDs from the database and to send that message to all the connections. So let me go ahead and update this code on messages. What this code is doing shortly, as usual, is everything starts with a handler. It initializes the API Gateway SDK, so with my domain name and my stage, which is test environment, and the API version, which is this one, it's default for the whole AWS SDK. After that is preparing the message in JSON format, which will be sent to all the connected clients, and it retrieves from database the existing connections via this function scan. It's scanning the table name messages and returns a promise, and in the promise it will return an items of connections. Going through each item, I'm receiving the connection and sending the message to each item, and since it's posting to the existing connection with the connection ID the data, which is in my case the message. And that's it. That's pretty much it. Quite simple. Let's save the code and let's make sure, well, here there are no connections in the database, and let's go ahead and try copy link. Let's try to initialize several connections. Let's make 3 clients. So this is going to be client 1, connected. Let's duplicate this tab. It's going to be client 2, connect. This is duplicate, will be client 3, connected. And right now let me show you all the messages. Let's say the client 2 one sends message from client 2, it sends a message. It received, the same client received his own message, and I expect the other clients to receive the same messages as well. So as you can see, message from client 2, message from client 2. And let's send message from the client 3, message from client 3. The client 3 should receive its own message, which is okay. Right now he has 2 messages, one from the client 2, another from the client 3, and the client 2 should have also the message from client 3. Client 1 didn't send so far any message, but he received both messages from client 1 and client 3. So it's kind of a chat. So message from client 1, send 1 message, 2, 3 messages from client 1. Right now client 2 should have 3 messages from client 1, and client 3 should have 3 messages from client 1. So it's a chat, it works. So that's how WebSocket Service API works on AWS. So that's it. If you have any questions, feel free to leave a comment, and wish you good luck with this thing. Bye.